All right, number one from section 1.5. Let's read the instructions first. Determine if the system has a non-trivial solution. Try to use as few operations as possible. And I wanted to do this one because I want to show you that you don't always have to put an augmented matrix in reduced echelon form. Sometimes it's enough to put it in echelon form to answer a question. Because really, it's enough to put it in echelon form to decide how many free variables there are, or what the free variables are. So in this particular case, it says, determine if the system has a non-trivial solution. Notice, by the way, this is a homogeneous system because all the constants on the right-hand side are zeros. And in a homogeneous system, there always exists a trivial solution. And the trivial solution of a homogeneous system is, well, the solution consisting of only zeros. That's the trivial solution, okay? We already know that's a solution of a homogeneous system. So the real question is, does there exist a non-trivial solution? Well, one of the facts of systems of linear equations is you're always either going to have no solution, one solution, or infinitely many solutions. So we know in this case we have at least one solution because it's a homogeneous system. We have the trivial solution. So the question is, do we have one solution or do we have infinitely many solutions? Well, if you have no free variables, then you will have exactly one solution, in this case just the trivial solution. If you have at least one free variable, that's when you have infinitely many solutions. And so that's when you're going to have a non-trivial solution. So it is enough for us to decide whether or not there exists a free variable in this particular case. And to answer that question, it's enough to put your augmented matrix in just echelon form and not reduced echelon form. That sometimes will save you a lot of work because they didn't actually ask us to find all of the non-trivial solutions. We just have to decide if there are any. So let's put this thing only in echelon form. So there's our augmented matrix. All right. Now, normally, if I were to put this in reduced echelon form, I'd start off by making the A to 1. But when you put these things in just echelon form, the first non-zero entry does not have to be a 1. It just has to be a number, a non-zero number. So in this case, I can leave that 8 the way it is. And I want to make these last two elements in that first column 0. And notice how much easier it is if I just add the first row to the second row to make that a 0. I don't have to divide by 8 if I want to put it in just echelon form. So I'm just going to add the first row to the second row. And notice if I multiply the first row by -2 and add it to the third row, it'll make that a 0. So -2 times that plus that is 0. -2 times that is 16 plus 8 is 24. -2 times that, I guess I better use a calculator. That's -46 plus 28 is -18. And the zeros aren't going to ever change when you do this. Okay. Now, remember, we're just trying to put this thing in echelon form in this problem. So the next thing I want to do, normally I would make this a 1 and make all the other entries 0 in that second column, but I'm just going to leave it as -12, and I'm going to only make this a 0 because I only want this thing in echelon form. So I'm just going to take the second row, multiplied by 2, and add it to the third row to make that a 0. So the first two rows are going to stay the same. But 2 times the second row plus the third row. So notice that's going to give me a 0 there because that'll give me 18 plus -18. Okay, so let's see if we can decide how many free variables we have. Well, notice that the first two columns are pivot columns. But the third column is not a pivot column because I can never change that entry into something non-zero. So the third column corresponds to a free variable. That means x3 is my free variable. I mean, I could keep going and put this thing in reduced echelon form if that would make you feel better, but it's really not necessary if you're just trying to decide what your free variables are and what your other variables are. So in this case, I know x3 is a free variable. That means this system has infinitely many solutions, so it does have a non-trivial solution.